So in this video we'll be going through how to add, multiply, subtract and divide using mixed number calculations. We'll also be going through what prior knowledge you need to be able to do this. So once you've mastered being able to add, subtract, multiply and divide with proper and improper fractions, then the next step is to be able to do this with mixed numbers. As mentioned, in order to be able to do this, your prior knowledge should be, now it's really important that you know the difference between these, because usually fractions is never anyone's favourite mathematical topic. However, because there are so many different things you do depending on which operator you're actually using. So the key thing is to know and not get mixed up between the four things. So the rules of adding, subtracting fractions, well, the main rule is that the fact that you need a common denominator. So if your denominator is not the same, then you need to go out your way to do that, and that's the only operator. So when I mean by operator, I mean add, subtract, multiply and divide, that you need to have a common denominator. When you're multiplying single fractions together, then the only thing you need to there do is to multiply the numerators together and then multiply the denominators together. Obviously the multiplying of the denominator, so in other words what you end up with for multiplying is you've got A over B times C over D, and what that then becomes is A times C and B times D. So you just multiply the two numerators together and that's your new numerator, and then you multiply your two denominators together and that'll give you your new denominator, and then obviously you can then simplify if it's possible. Then with dividing, so the rule of dividing is you always flip the second fraction and then you replace the division symbol with times. And then it becomes like the times question, where you multiply the two numerators together and then multiply the two denominators together and then simplify where applicable. And then the also thing you need to be able to do is simplify fractions. So this is where we divide both the numerator and the denominator by their highest common factor. So in other words, you need to divide both the numerator and the denominator by the same number until you can't do no more. And again, not all fractions can be simplified, and we definitely don't use decimals as numerators or denominators. And the last one is converting improper fractions to and from mixed numbers. Now for this, and again just a little refresh on this to quickly do it. So if we go from mixed to improper fractions, now in a mixed number you've got a big number and you've got a little fraction which is going to call A and B over C. And so if we multiply the big number by the denominator and then we add that to the numerator of the small little fraction, and then we have that all over C, then that will convert that into a improper fraction. So an example of this would be if I had let's say 3 and 2/5, then I would do 5 times 3, which is 15, plus 2, which is 17, so that would give me 17 over 5. And then if we're converting improper to mixed, well, if we had an improper fraction of A over B, where A is bigger than B, then what that does, if we turn that into a full stop question, and we've got A here, and if I call this, and I'm going to have lots of letters, so if I call this your D and your remainder R, then what this would then become as a mixed number, it would be D and then your remainder over B. So in other words, if I had to work out what let's say 20 over 3 was, now again you can kind of do this in your head, and you don't really have to use bus stop method, you only really have to use it for more complicated questions. So how many 3's going to 20? Well, that would be 6. The remainder would be 2, because 3 times 6 is 18, so I'll have 2 left, and the original denominator is 3. And so there we've converted an improper fraction into a mixed number. And remember, you can only convert improper fractions into mixed numbers. You can't do that with proper fractions. So let's have a look going into adding. Now I'm going to start off with doing some quite simple questions where there's nothing really much to read. It's quite self-explanatory what you've got to do, and then I'll go through some worded questions where it might not be obvious as to which mathematical operator you do. but it's just a case of working through, and you highlight. With practice, with these worded questions, you'll kind of get an idea, and it's basically just using common sense to know when to add and when to multiply. Sometimes when you're given fraction questions, if that's what's throwing you off, just imagine it's just a whole number, and then think to yourself, how would I answer this question if the numbers were whole? And then you just do exactly the same, replacing the whole number with fraction. So anyway, so back to this. Now the first thing we want to do, I'm going to get rid of this light blue pen, so let's go for purple. Now I'll try and do the methods of what I'm actually doing first when we're adding and subtracting. So here all we're going to do is add these two mixed numbers together. So the first thing you want to do is convert any mixed numbers into improper fractions. Now there is a way of adding and subtracting using the face value, but I personally would say that it might be easier for you to do this. Now another way of doing this, so one way is going to be the way that I'm going to show you what I'm talking about. The way that you can do it is, because you're adding and subtracting, you could in theory see this question like this. Now when we're adding, the order doesn't make a difference, so 2 plus 3 is the same as 3 plus 2. So how I could do this, I could add 3 plus 6 plus 1/5 plus 1/4, and then if I then work out what this is, I could then add that to the 9 that I get from adding 3 plus 6. Now personally, it's a lot of faff, and when you're moving into subtraction, it can sometimes work and it can sometimes not, where the method I'm going to show you kind of works with any types of questions, and although it's a little bit longer, it might prevent you from making a silly mistake. So the first thing we want to do is convert any mixed numbers into improper fractions. So here this is going to equal 3 times 5, which is 15, plus 2, which is 17, over 5, and the denominator stays the same, plus, and then 6 times 4, which is 24, plus 1 is 25, and that's over 4. Now the next thing we then want to do is get the common denominators. So common denominators. Now in this particular case, our common denominator is basically the smallest number that appears in both the 5 times table and the 4 times table. So with number 2, so the smallest number that appears in both is 20. And then what we then need to do is think to yourself, well, what have I multiplied this first fraction to get a denominator of 20? Well, I've times that by 4. And what have I multiplied 4 to get 20? Well, I've times that by 5. So to get the new numerators, that is basically what I need to do. So I need to multiply 17 by 4, 25 by 5. So I do 17 times 4. I get an answer of 68. And let's use a different colour pen. And if I do 25 times 5, which I get is 125. Now once the denominators are the same, is then what we need to do is either add or subtract the numerators. Now the key thing with regards to this, and not to get confused with multiplying, which we'll move on to next, is that the denominators stay the same. So the denoms stay the same. So the only thing we're doing is affecting the numerators. So with number 3, I've got 68 plus 125 all over 20. And if I work that out, so 68 plus 125 gives me 193. And that's over 20. And then the fourth step, because this is mixed numbers, if you end up with an improper fraction, so if the answer is improper, convert into a mixed number. So with step 4, we've got 193 over 20, and so if I work out how many 20s go into 193, well, that would be 9, the remainder would be 13, and our original denominator is 20, and there is our final answer. Now the rules and steps which I've done for this are going to be exactly the same for subtracting, so you might be worth making a note of those 4 steps, which is basically what we're looking for. Now not all 4 steps are going to be applicable, It all depends on you practicing your questions and understanding which steps you can kind of miss because it's already done for you or it's not applicable in the question. So let's have a look at the next question. So this is an adding Wordy question. So it says that Ashika plays football. In the first half she covers a distance of 8 2/3 of a kilometre, and in the second half she covers 6 5/8 kilometres. In total, how much distance did she cover? So again, if I'm not too sure, let's say she ran, I don't know, 8 kilometres and then she ran 7 kilometres in the second half. Basically what I would do is I would add these two numbers up. So for this particular question, what I need to do is add 8 2/5 plus 6 5/8. Let's just get this so we don't get confused. So that's basically what this question is asking me for. This is converting a worded question into a basic question where it's quite self-explanatory what I need to do. So going through the first step, what I need to do is get convert them into improper fractions. So here we've got 8 times 3, which is 24, plus 2, which is 26. That's 26 over 3. And then I've got 6 times 8, which is 48. Add the 5 gives me 53 over 8. So not the nicest of fractions because of the size of the numerators, but again the method is exactly the same. So let's do step 2 over here. So the next thing I need to do is get a common denominator. So I asked myself, what is the smallest number that appears in the 3 times table and the 8 times table? And that would be 24. And so I need to multiply this first fraction by 8 to get 24, and I multiply the denominator in the second fraction by 3. So that's what I need to do to get the new numerators. So then if I do 26 times 8, I get an answer of 208. And if I do 53 times 3, I get an answer of 159. And then for step 3, all I then need to do is add the two numerators together, remembering that the denominator stays the same. So if I do 208 plus 159, gives me an answer of 367 over 24. Now if I then check to see if that simplifies, it doesn't. So then what we then need to do is convert this into a mixed number. And if I convert that into a mixed number, I ask myself how many 24s go into 367. That equals 15. A remainder is 7, and I'm dividing by 24. So there is our final answer. And again, not forgetting the units. Now, I'm not going to lie, even though I'm a maths teacher, I did cheat on that question by using a calculator just to make things a little bit quicker. So although, as I mentioned, that most of these mixed number questions will appear on a non-calculator paper, if you've got the luxury of when you're revising to be able to check your answers with a calculator, then that's good sort of common sense. Now, when entering numbers on your calculator, and again, most of your calculators will most likely be a Casio one if your maths teacher's been recommended, because they usually make some of the most decent ones. Now, to enter mixed numbers on your calculator, many people would press the fraction book, which you know. So if I entered, what was the number we were looking for? 8 2/3. They would enter the 2/3, and then what they will do is they'll scroll across and enter a big 8. Now the problem with this is the fact that that has been entered incorrectly. So although it looks absolutely fine, what this is actually doing is it's going to multiply 8 and multiply that by 2/3 rather than it being 8 2/3. So for this, when entering mixed numbers on your calculator, then what you need to do is you need to press Shift. Now, and then if you press the fraction button again, it actually comes up with the 3 boxes. So you've got the actual whole number, and then you've got the 2 boxes for your fraction. So with this, I'm going to enter, it was 8 2/3. This is a bit awkward on the computer. 8 2/3, and then I scroll across, and I need to add, what was I adding? 6 5/8. So again, I'm going to press Shift and the fraction button. Well, that hasn't worked, so let's delete that. So Shift and the fraction button, there we go. And we've got 6 5/8. So let's scroll across, 5 and 8. and press equals, and again you can see that it's come up with 367 over 24. Now as you can see, that's not given to me as a mixed number, even though you can clearly see that it's an improper fraction. So what I can then do to convert that into an improper fraction, if you press shift and then press the SD button, you can see that it converts it into a improper fraction. And obviously if I press the SD button, it converts it into a fraction and a decimal, but if I press shift and that SD button, it comes up as a mixed number for me if the original part is a improper fraction. So that's giving you a bit of an insight on how to enter mixed numbers on your calculator. So just to go over, so you press shift and then the fraction button, and then you enter your mixed numbers. Try not to enter the fraction and then scroll across to enter the big number. It doesn't work, it's not going to like it, and it'll definitely give you the wrong answer. So let's have a look at the next part. So this time, if I'm not mistaken, is subtraction. Now subtraction is done in the exact same way. So again, the first thing we want to do is convert both 5 and 5 sevenths and 3 and 3/8 into improper fractions. Now again, with practice you should be able to do this in your head. So I've got 5 times 7, which is 35, plus 5, which is 40, and the original denominator stays the same. And I've got 3 times 8, which is 24, plus 3, which is 27, over 8. Then we want to try and get a common denominator. So in this case, it's going to be 56. So then I need to multiply this fraction. What's happened there? Now let's just get rid of that. So we're going to multiply this fraction by 7 and this fraction by 8. So I've got 4 times 8, which is 320, or 40 times 8 rather, and then I've got 27 times 7, which gives me an answer of 189. And then the next thing I then need to do is just simply subtract the two numerators together. So again, I'm subtracting because it's a takeaway question. So I do 320 minus 189, which equals 131 over 56, so which is absolutely fine, but as that's a mixed number, an improper fraction rather, I can convert that into a mixed number, which gives me an answer of 2 and 19 56s. And there is your final answer. So you can see there that the method is exactly the same. The only thing that's different is because we're taking away, we just subtract the denominators, the numerators rather. The denominators stay exactly the same. So let's have a look at a worded question. So here it says that Dylan was driving to university. I don't know what's come up there. So it says Dylan was driving to university, and his journey took 3¼ hours. However, he was stuck in traffic for 1 3/10 of an hour. How long would the journey have taken had there been no traffic? So again, now with time and fractions, you may be able to work this out in terms of hours and minutes, and if that's the case, then you'd probably still be okay. But as this is a fraction questions, we're going to use what we've done to work this out. Now again, if you're not sure, let's swap this for 3 hours, and let's say this was 1 hour, and then so if we swap the fraction for 3 and 1 respectively, then you could see that the answer therefore would be, well, he's travelled 3 hours, he was stuck in traffic for an hour, so the answer is going to be 3 take away 1. So for this particular question, what it's asking me to do is do 3¼ minus 1 3/10. So that's basically what the question is asking me to do. So again, let's get rid of the 3 and 1 so you're not getting confused. So first things first, we notice that our numerators are not denominators aren't the same, so let's convert them. So we've got 3 times 4, which is 12, plus 1, which is 13, so I've got 13 over 4, minus, and I've got 1 times 10, which is 10, plus 3, which is 13 over 10. So now, although our numerators are the same, our denominators aren't, so we need to convert them, and the smallest number that appears in both the 4 times table and the 10 times table is 20. Now if you were to use 40, that's fine, but you just have to simplify your answer. So if you think smart, less work to do. So for this, what we then need to do is multiply this by 4, and this, we've multiplied it by 5. No, we haven't. We've multiplied this one by 2 rather. And we then need to work that out. So I'm going to do 13 times 5, which is 65. And 13 times 2, which is 26. So for step 3, I just need to take away 65 minus 26, which gives me an answer of 39. So that's 39 over 20. And again, how I've got that is by doing 65 minus 26 all over the same denominator. And as that's a mixed number, how many 20 is going to 39? That'll be 1. Remainder of 19 over 20, and that's in hours. And there is our final answer. So moving on to, let's look at multiplying. So again, for this, the rules are simple. So let's go through a method of what it is I'm actually going to be doing. So the first thing we need to do with multiplying is make sure that the denominator, we need to convert into improper fractions. So just like we did with adding, subtracting, the very first step we need to do is convert into improper fractions. The second step we then need to do is then just multiply the numerators together and then have that over the multiplying the denominators together. And then what you then may want to do is simplify if possible. And it might be possible to do that. And the third step is then the other thing we then need to do is if improper, the answer, that is. So if the answer is improper, let's just write that out again. So if the answer is improper, then what we need to do is just convert into a mixed number. So following the 3 steps, so let's do the first one. So you can see here that we've got 2 sets of mixed numbers. So the first thing we want to do is convert both these 2 fractions into improper fractions. So I've got 6 times 5, which is 30, plus 2, which is 32, and that's over 5, times 4 times 3, which is 12, plus 2, which is 14, and that's over 3. The second step is then all I need to do is do 32 times 14 over 5 times 3, and that gives me an answer of, so 32 times 14 is 448, and that's over 15. So if I divide that by 15, I ask myself, does it simplify? No, it doesn't. So I've got 448 over 15. And then to convert this into a improper mixed number, I ask myself, how many 15s go into 448? Well, that'll be 29. And then I've got a remainder of 13, and the original denominator is 15. So there is my final answer. So again, these 3 steps apply to multiplying with mixed numbers. And again, the first thing you want to do is just convert, all you've got to remember is just convert it to an improper fraction first. So if you have any mixed numbers, and then it's just straightforward fractions. And then trying to simplify where you can. Now, some people, you might be able to simplify your fractions to make life easier at this stage in step 1. So, for example, if 3 went into 32, I could cancel those fractions down. If I could simplify 14 and 5, then I can cancel that down. So there's different things, and depending on how you've been taught and what you look for and what your skills are in fractions, you might be able to make your life a little bit easier rather than just simply waiting for everything at the end and ending up with huge numbers. So let's have a look at a multiplying contextual question. So contextual is just where fractions are used in a non-fraction format. So here we're combining fractions with area. So the question is asking us to find the area of the shape, and this shape is a rectangle. And how do we find the area of a rectangle? Well, it's simply the base times the height. So these are the kind of thinking that you want to look for. So the area is the base times the height, or the length times the width, whatever floats your boat. So for this, what I'm going to ask you to do is do 4 2/5 times 2 1/2. So again, going through the steps, I want to convert both these 2 into improper fractions. So I've got 22 over 5 times 2 times 2, which is 4, plus 1, which is 5 over 2. I then want to multiply the two numerators together and multiply the two denominators together, in which if I do 22 times 5, I get 110. And I've got 10. Now this one, it does simplify. So at this stage, I notice that both numbers can be divided by 10, in which then the answer is just going to be 11, and the units are going to be centimetre squared. So that one's actually worked out quite nicely. If it was a fraction, again, not a problem. If it's a proper fraction, can't simplify it, leave it as is, don't forget the units. If it's an improper fraction, then convert to a mixed number, and again, don't forget the units. So let's have a look at the next one. So here we're looking at dividing. So again, let's just write down the steps for us to do this. So the first thing we want to do is convert into improper. What's going on with the R in that one? So to convert into improper fractions, so that's the first step. The second step is then all we then need to do is abide by the rules of, or the method of dividing fractions. So we flip the second fraction, and it's always the second fraction, never the first, and then replace the division symbol with times. And then all we then need to do is then multiply the two numerators together, so it becomes exactly like a multiplying question, over multiplying the denominators together, and then we can then simplify if possible, and then the fourth step is if the answer is an improper fraction, then just convert it into a mixed number. And that's our step for dividing with mixed numbers. Now, the key thing with regards to this particular question is that this question does use the division symbol. And what you'll find is that with some questions, now this question, so if I had 3.5 divided by 1 2/5, it could be written as 3.5 over 1 2/5. So those two formats are exactly the same. The difference is that with algebra we tend not to use the division symbol. Instead we write things as a fraction. So just be wary that these two things that I've got here are the exact same question. It's just set out differently. So back to the question then. So the first thing I want to do is convert these numbers into improper fractions. So I've got 3 times 2, which is 6, plus 1, which is 7, so it's 7 over 2, divided by 1 times 5, which is 5, plus 2, which is 7 over 5. So what I then need to do is flip the second fraction, so that becomes 5 over 7, and replace the division symbol with a multiply, and we've got this. Then the third step is I multiply my two numerators together and multiply my two denominators together. So I've got 35 over 14, and which then, if I can divide both numbers by 7, so I get 5 over 2, in which what I could have done is simplified here. So I've got 7 on both sides, both the top and the bottom. I can cancel that down to give me 5 over 2, but again, it doesn't really matter. And as 5 over 2 is an improper fraction, I can convert that into a mixed number. So I ask myself, how many 2's go into 5? Well, that will be 2. What's the remainder? 1. And our original denominator is 2. So let's have a look at a worded question. So it says that Dhruv is at school for 8.25 hours and is in lessons for a total of 8 3/5. What fraction of the day was he in lessons? So for this, and again, if you're not too sure, let's simplify this question. So let's change 8.25 for, let's say, just 8 hours, and 6 3/5 to, let's say, 6 hours. So we want to write this as a fraction. So Dhruv was in lessons for 6 out of 8 hours. So I'll be doing this fraction, which is 6 3/5, over 8 1/4. So first things first, I'll just get rid of this so we're not getting confused. So this is the question that I need to work out. And I need to make sure that I'm writing it as a fraction. So looking at this now, you can also see, just using your common sense, is that here the numerator is clearly smaller than the denominator. So when I work this answer out, it's important that I use a bit of common sense and establish, right, okay, what am I expecting? Well, if the top number is smaller than the denominator, it means that my answer should be a proper fraction. So if I don't end up with a proper fraction, I've definitely gone wrong somewhere. So let's have a look at working this out. So let's look at #1. So let's write out the question as we did in the previous question. So I'm going to use division symbol, just so it's easier for me to set it out. So what I'll do is convert this into improper fractions. So I've got 6 times 5, which is 30, plus 3, which is 33 over 5. And then 8 times 4, which is 32. Again, coincidence, we end up with 33 again. So from this, we want to flip our second fraction. So I've got 33 over 5, that stays the same. And so I've got 4 over 33. And I change that to a times. Now I can either work that out, or I can use a calculator to work it out, or I can simply recognise I can start cancelling, simplifying. So I know 33, so that becomes a 1 like that. Or I could just do 33 times 4 over 5 times 33. If it's on a non-calculator, you would actually need to work out those two values separately. If it's a calculator paper, you can just plug it in. So here we've got 33 times 4, which is 132. And we've got 5 times 33, which is 165. Now I can simplify this fraction because it does simplify to give me 4 over 5. And there is my final answer. Now, I'm going to leave it as a fraction for obvious reasons, because the questions asked me for what fraction of the school day is he in lessons. Now, what is good practice when you are doing this is to make up your own questions. But however, don't try not to use crazy numbers, although if you really want to practice your general arithmetic skills, then go for some crazy numbers. And also then check your answers on a calculator to make sure you've got it right, which is a really, really important thing. Now, I know that fractions is probably one of the most detested topics in maths that you've probably learned at school. It's been taught over and over again, regardless of what year you go through. But if you speak to anyone or any adult who says that they weren't very good at maths, or they didn't like maths, one of the reasons why is because they didn't understand fractions and also algebra as well, which also tends to be not a fan favourite. But if you are wanting to be really good at maths, then mastering these basic skills, and fractions is a basic skill, it is something that will make your life a little bit easier, particularly when you are learning with maths and developing your maths skills, is being competent with working with fractions and not being put off by working with fractions, regardless of if it's quite a basically written question or if it's a worded question.